Thanks for coming. This is our third in the series of talks on Authorization Based Access Control. Today we have Tyler Close from HP Labs, and he's here to talk about a system that he's designed and worked on called the Webkeys. And with that, thank you very much.
Thanks. All right, so previously in the talks, we've taken a look at capabilities primarily within the setting of a local computer. Today I'm going to switch things up a little bit on you, and I'm going to look at capabilities primarily in a distributed setting. And so we might find some uses of capabilities here which might be directly applicable to work that you're doing right now. So Alan Kay once set a very high design standard for languages and other systems. Simple things should be simple, and complex things should be possible. It's a pretty high bar to meet. It sets the bar pretty high. But once you find something that meets that criteria, you've really got something. And the reason that we've been here giving this series of talks at Google is because we think capabilities are something that meets this very high standard. Earlier in the TechTalks series, Alan and Mark presented some areas where capabilities achieve some fairly sophisticated features that fairly feasibly. And so we've seen that using capabilities, the complex is actually fairly feasible. Today I'm going to back away from that a bit, and I'm going to concentrate just on the simple things that you can do using capabilities. It's surprising how many simple problems we have to solve in our day-to-day work that can be made complex by the wrong tool. And we're going to see how to solve some of those problems using capabilities in a relatively straightforward way today. So here's the talk overview. I'm going to begin with an anatomy of a capability. And so this will be a little bit of review for people who are just joining the Tech Talk series on capabilities. And this review will also serve to set up the needs, the requirements that we need to meet in order to get the properties that we've been talking about, capabilities in the local context, to get those same properties in a distributed context where the callee and the caller are potentially on separate computers. So once I've set up and laid out exactly what a distributed capability is, I'm going to show you some interesting ways of using it. And I'm just going to show you a couple of patterns that you can use on the client side of a program. So just purely you're the client of a capability-based application. What sort of neat things can you do because the server application happens to be capability-based? And then on the server side, what sort of interesting implementation tricks do you have at your disposal to make your implementation life easier? And I'm actually only going to show you a couple patterns of each. We're going to spend the whole talk going over those 4 patterns, but I'm going to show them to you from a variety of different perspectives. I've got some actual running code here today, and so we're going to be able to see how these patterns affect the graphical user interface that a user sees when interacting with the application. I'm going to pull up some view source screenshots so that you can see what is actually going across the wire, what the network interface to your application is. And then finally, I'm going to show you some source code of how this stuff can actually be implemented on the server side. So let's start with a little bit of review here. So this diagram is familiar from Alan Mark's talks. We call it the Granovetter diagram. You'll see us go back to it quite frequently because actually what it is it encapsulates very well all the properties that you need to implement in a capability system. This diagram, it's sort of the atomic unit of collaboration. So it's expressed twice up there. We've got the graphical picture of it, and then we've got what it might look like in an object-oriented language implementing what's described in the diagram there. So each of the spheres, you can think of them as being, one way of looking at this diagram is to think of each of the spheres as being an object, and the red lines as being object references, and the fat purple arrow as being a message or a method invocation. And so what this diagram is depicting when you're looking at it as a collection of objects is the implementation of Alice contains a reference that refers to the Bob object, and Alice is invoking the foo method on that, passing as an argument her reference to Carol. Now let's think about what the language runtime needs to guarantee in order for this to be a useful statement to write in the language. what we're trying to do here is set up a collaboration. Alice has pointers to the Bob and Carol objects, and she wishes to get them to collaborate for some purpose of computation. So let's imagine that Carol is a callback function, and Alice is registering her callback function with Bob, with the expectation that Bob will then deliver a series of events to that callback that Alice is interested in receiving, and that'll set up the collaboration between these objects. Well, the first thing we need to guarantee in order for that to work is that when Bob sends messages along the reference he received in the foo message, that his messages get delivered to the object designated by Alice. So when Alice passed a reference in that foo message, we want to make sure that the object that's at the end of that reference is the one that will receive the messages, the callback messages, that Bob is sending. Were some other object able to insert itself in there and receive those callback messages, then we will have failed to set up a collaboration, right? Because Alice is expecting to get some callbacks, and she'll never get them. Some other object will be getting them if Bob's messages aren't delivered to the Carol that Alice designated. So let's imagine further that maybe Carol is a special kind of callback. Carol is a callback that writes her callback arguments to a log file. And so every time this callback gets invoked, it's going to write out a line in a log file. And so Alice has authority over this log file, and Alice has been authorized and given the permission to write out to this log file, but she now wants to delegate that access to Bob. In order for the collaboration that we're trying to set up to work, that means that the log file has to write out the log statement regardless of who's sending the invocation, Alice or Bob. So when Alice passes that reference to Bob, Alice's authorization to use that file has to travel along with it. If this weren't the case, let's say that we're using an identity-based access control system, then it might be the case that when Bob invoked the callback, which caused a log line to be output, that he would get an access denied error, and we would have failed to set up a useful collaboration. So in order to get these objects to collaborate, there are these two main features that we need to implement on the object reference that's traveling here on this message, this red line here. It needs to provide Bob with a way to know that he's talking to the Carol that's referred to by this reference, and it needs to carry with it Alice's authorization to use Carol. If we can guarantee those things, then we can set up a useful collaboration scenario. And so now what we're going to look at is in a normal language runtime environment, just your language, your virtual machine, or your programming language provides these guarantees for you. Objects can't jump in and intercept method invocations that were intended for you. And when you pass a pointer, it doesn't matter, you can use that pointer from anywhere in your program. But now we want to get these properties in a distributed context. And so that's what we're going to look at how to do next. And we've got two slides coming up. The first one will be on setting up this authentication property. Question?
Yeah, why do you prefer not to model that Bob writes to Alice's log file by asking Alice to do the final work?
Well, where does that bottom out? If no one can ever do a direct delegation, where do any of the calls bottom out? You've got to forward everything all the way back to the origin every time?
Well, where did they bottom out in any case? I mean, I was assuming that Alice had the ability to write to the log file already.
Right, and so she wants to delegate that authority to Bob so that Bob can then write to the log file. And so Alice is stepping aside and moving herself out of the invocation chain by doing that delegation. And that's a key step for managing complexity, where Alice required to remain in the delegation chain every time she passed a pointer, you get spaghetti code.
Are you going to talk about how Alice would limit the scope of Bob's authority?
So we've talked about that a bit in the previous presentations, but yeah, Bob's authority is essentially the reference to Carol. And so all the authority represented by that reference is all the authority that's being delegated, that and nothing more. And so that's how you limit the scope of the authority that's being passed. So I was going to stop at this point and point out how bizarre these two requirements actually are if you sit back and think about how authentication and authorization are typically thought of. But I'm already getting questions, but I'll put my head in the lion's mouth anyways. It's kind of odd when you think about it that Bob doesn't care who Carol is. all Bob wants to do is make sure that the messages he's sending are being delivered to the object that Alice designated. If you think about what we normally think about when we're doing authentication, so for instance, you connect to a website and you get back an X509 certificate, it's got all this information coming from the site that you connected to, giving you metadata about who it is and you know, where it is, who it belongs to. And most of the time, that's actually pretty irrelevant to you. All you want to make sure of, and actually all the cryptography is actually guaranteeing you of at runtime, is that you're connecting to the site that's referred to in the URL you clicked on. And so it's strange that, there are all these extra properties there that are thought to be needed, but when we look at it purely in terms of what authentication do we need to enable collaboration between objects, we get a much simpler scenario. All right. So we had the two properties that we needed to provide in this reference that we're passing from Alice to Bob. The first was we needed to make sure that when Bob goes to use the reference, he knows his messages are being delivered to the target that Alice intended. So we need to make sure that we've correctly authenticated Carol. So the way that normally happens on the web today is by leveraging the DNS. And so in the authority component of the URI string, you've got a DNS domain name. And there's a complicated story that explains how that domain name gets mapped into a public key, which your computer can actually authenticate at runtime. And that's kind of annoying, because really we have this rather simple property. We just want to connect to the site that this string says we could connect to. And so a way of getting an implementation that more closely reflects those semantics would be to do something like this. And so I'm going to extend the domain name here with a prefix that is the hash of the public key that you should connect to. And so now when Bob's computer receives this URL, he knows, okay, well, I'm supposed to send messages to the target designated by this URL. All right, I'll set up an SSL connection, and I'll make sure that the remote side is signing this SSL session with a public key that matches this hash. And if so, I know I'm sending my messages to the target I was told to. So there's some interesting implementation bits also on this slide. One thing that may jump out at you, and that seems a little odd, is that public key hashes tend to be rather noisy things. They've got a lot of bits in them. And so I've turned our domain name from what was conceivably something that was human memorable to something which you'd probably have to write down, and it would be sort of awkward to do that as well. Well, the first point is that the vast majority of URLs that you use, especially URLs that are being used for communication between programs, are never going to be seen by human eyes. They will either be solely manipulated by programs, or they'll be hidden in href attributes in HTML. And so the fact that it looks ugly most of the time is pretty much beside the point. However, there is the odd case where you've created a new company, you've got a rather important page that's going to be meaningful to a lot of humans, and you want to write the address of that on the side of a bus. Well, this obviously isn't something you're going to write on the side of the bus. But really, was it ever the domain name that we actually wanted to write on the side of the bus? Wouldn't it make more sense that if I've got a business and I want to attract attention to it, that I would put my trademark on the side of the bus? And if that's the case, then all we really need is for those few cases where we need to map from the world of trademarks to the world of secure references, we need some sort of service that can take keywords like that, like trademarks, and somehow map them into a URL. A service that could take keywords and figure out which URL was the best match for that keyword. I know I've heard of something sort of like this somewhere before. You guys are pretty smart. Do you guys at Google know anything about such a service? So I'm going to take a little break from the presentation here and push on this one little point a little bit more, because I think it's an interesting opportunity that I very much wish Google would pursue. And that is, if you look at the reality of how Google is used today, Google's a trademark repository. If I find a company that I want to know more about, I look up its trademark on Google, and Google will return to me as the top hit a pointer to its homepage. Google is the one mapping trademarks into website addresses. They're already fulfilling a role very similar to that CAs perform. And so what would happen if you put a CA-like user interface on Google search? What would happen if, let's say, you extended the Google toolbar such that it had a little field in it that when I connected to an SSL site, it got the key, the public key from the site, went back to Google and said, so who's using this public key? What trademark is it associated with? And the Google search engine would come back and say, as far as I can tell, this isn't associated with any clear trademark. Or, hey, you know, PayPal's been using that key for the last 5 years. And that sets a really different scenario for using cryptography on the web. Basically what you do is, you know, you've got a new business, you just make yourself a public key and start using it. And once you've established enough PageRank cred that you've got the Google whack for your trademark, then you start plastering your trademark on the sides of buses. And there was never any real need to pay someone else to recognize the fact that you've actually been using this trademark. You guys have a search engine that is exceptionally good at determining what's the canonical resource for consulting for a given trademark. And it might be interesting to see what would happen in the CA industry if you just changed the user interface that you're putting on that. All right, back to the presentation. The second part, the second feature that we need to provide in this reference to Carol is we needed to transfer Alice's authority to have messages processed by Carol. We needed to transfer that authority to Bob. Well, in a distributed computing scenario, basically the only way of having authority is to possess a secret that others don't, some secret bits. And there are various ways of transferring it, but because of the way the web works, I suspect the most feasible way of transferring that authority from Alice to Bob, in this case, is just going to be to embed the secret in the URL. And so Alice has a URL that has the hash of Carol's public key and a secret in it that's possessed only by Alice. Only Alice knows this URL. This URL was delivered to her securely, and so she can use it to send invocations to Carol. Now when she wants to delegate that authority to Bob, all she does is transfer that URL to Bob using a secure medium. So for instance, it might be over another, in this case, in the diagram we drew, it would be over another SSL session between Alice and Bob. But you could also use secure email or other options. There's a question at the back? That's an excellent question. So the question was, so Alice has a bunch of authorities, and she only wants to transfer a subset of them to Bob. And further, what if Carol represents a rather complex service, and Alice doesn't want to give all of Carol to Bob, only wants to give part of Carol to Bob? How would she go about doing that? And we're going to see some patterns coming up in the next couple slides showing you exactly how to do that. So let's keep moving right along then. So this slide here just puts together what we saw in the last two slides. This is the full URL that Alice possesses for Carol, the one that she's going to transfer to Bob. And so notice that it's actually a fairly usable string. This one here is 53 characters long. It's not going to suffer from line breaks if you send it to someone in an email. The other important thing to note here is that I put both the authentication for Carol and Alice's authority within a single URL string. Now this is crucial if what we want to do is enable collaboration using web technologies. We have HTML and HTTP and other tools for passing around URLs. If we want to use these tools to also enable collaboration when there's some authority involved, then we need to make sure that our representation of authority fits within the slot that our existing tools have for references. And so we can put this URL, because it's a URL, anywhere we're currently putting normal URLs. There's one caveat to that, though. Sometimes we're pretty sloppy with URLs, and we put them in places where they'll be discovered by people we didn't intend. And so when we're making use of our existing tool set with these URLs, we have to put some thought into how the tool is going to be transferring the URLs and make sure that it's going to reflect our wishes. So for example, if I have a browser with an end-to-end SSL connection to a server, then that's a pretty safe scenario to be using these URLs because they're being delivered, they're only visible on the server and on the client, and in between they're under end-to-end encryption. One caveat that to, though, might be, well, what if you've installed a plugin? I don't know. I know some companies are distributing plugins that go and snoop through and watch the URLs that you're visiting and transmit them off to third parties. And so you'd want to make sure that that sort of spyware isn't installed on your computer. It would certainly not be good if, just as a general principle, it'd just be a bad idea to have software sitting on your computer, plucking data out of an end-to-end encrypted session and transmitting that off to third parties. That's obviously defeating the intended purpose of the end-to-end encryption. And so you'd want to make sure that you didn't have anything like that running on your computer. So let's get to the patterns, the fun stuff. We now, another question at the back.
So your capabilities are just purely bits, right? They're not distinguished in any fashion. So the famous star problem, in fact, is an issue with this. You can't enforce multi-level security because they can leak capabilities.
Yeah, so keep in mind that at the start of this presentation, I said we were going to be talking about capabilities in a distributed context. The star property doesn't make any sense in a distributed context. The only way to implement the star property is if all parties are using the same computer, and that computer can therefore put checks on how those parties can communicate. If you're in a distributed context, I have my own computer, you have your own computer, I've been given some authority by a third party, there's anything he can do to prevent me from transferring my authority to you. Okay, and so the star property is just irrelevant when you're talking about distributed computation. All right, so I've got the two client-side patterns. So the first one we're going to look at is actually the one we had a question about. So what happens if the thing that I want to delegate actually represents more authority than I want to delegate? How do I cope with that? And so I've got an interesting story here. One of the members of our group was recently at a conference, and one of the principals at one of the major e-commerce companies was giving a speech, and in that speech bragged about the fact that their services were so sophisticated that some of their implementations were testing the limits on the number of methods their compiler would allow per class. So that's the world we have to live in. We have people out there that are going to design services like that, okay? And so what we need is a collaboration paradigm that's going to allow us to cope with the existence of those designs. Keep in mind, this was a major e-commerce company that was doing it, and so I might have very good business reasons for wanting to interoperate with this very poorly designed service. I need to do it, and so I need a tool that's going to make that as easy as possible for me. So the question that was asked earlier, how can I decompose this huge chunk of a thing I've been given into something that's smaller and usable for me? How do I get at the part of it that I want? So the answer to that is that it must be possible for the client to decompose the authority. And watch the words that I'm using here. It must not be just possible for the authority to be decomposed. It must be possible for the client to decompose the authority. So as an engineer of questionable skill, you've designed a web service that represents a whole lot of authority and passed to me that authority. As an engineer of somewhat greater skill, I need to be able to decompose that authority without any help from you, because if I require your help, I'm not going to get it. And so how do we cope with that? Well, this is actually a fairly familiar problem for you guys here at Google. So we've encountered this problem in the past. So Google has this wonderful thing where I can ask it for a particular kind of information, and it can give me back a page of search results that are only related to that information, giving me direct links to those pieces of information out of the whole web. And it doesn't matter how bizarre and convoluted the site's navigation system is, Google can make that site's content accessible to me, even though the site doesn't make it accessible. That's amazing. How does Google do that? Well, the answer is deep linking. Google's search engine goes through and traverses the labyrinth, goes through all the Byzantine navigation systems that the site has hidden its content behind, and pulls out a direct reference to the content of interest, and then just hands off that direct link to me. And so me, as the consumer of that content, I didn't have to traverse that bad navigation system. I didn't even have to know it existed. Google just traversed it for me and gave me the direct link. So to solve this problem here, we need something similar. We need an access control mechanism that supports deep linking. And that's what capabilities are. So the way you build up your application, the way you make a network interface to a capability application is you construct a reference graph. And a client interacts with the server by traversing that reference graph, sometimes invoking methods, sometimes just doing a get, and finally coming out with the thing that's of interest. And then we can do the Google trick. We can take back the capability for the thing that we found, the thing of interest, and just pass that off directly to the person we want to delegate to. So now I'm going to actually show you some code. We're going to see an example of doing this. I've designed some bad code for you. So here we have a rather simple web service. This web service just provides me with a single editable text blob. And so I can go in here and write some text, and it'll save it for me. And I can connect to this from any computer and save some more notes here. And that's sort of a useful thing to have some place where you can write some notes. But it's not as useful as I'd like, because when I connect to this thing, I've got read and write access on it. And so what if I want to make my notes accessible for other people to read, but I still want to be the only one who's modifying my notes? How would I do that? Well, if this were designed under a classic ABAC style, I would have a password for this service, right? And my password would give me access to all the things I'm allowed to do at this service. And so the only way for me to delegate to someone else is for me to give them my password, but then they've got my write authority, and that's no good. I didn't want to give them that much. So I need some way to decompose the authority I've been given, to split out just the authority to read this text, and then delegate that to someone else. Well, let's take a look. This one actually is a capability-based application. So I'm going to do a view source on it. Nuts. Come down, come down. All right, I think we can see enough of it. Firefox has decided to put the window way up and away. The important parts, though, are you can see that the text that I was editing isn't actually displayed in this view source. It's not there. The thing that I was looking at was the top of a hierarchy of authorities that I have over this resource. And so one of the authorities I have is the authority to assign. So you see I've got this other key here. And so when I hit save text on that form, it did a post to this URL here, overwriting the previous text with the text that I had just written. But then how did the form get initially populated with the text that I wrote earlier before coming here? Well, it fetched that text using this authority here, the value. And so it did a get on this URL here, and the server returned to it the current text that's being stored for this editor. And so to delegate to someone else, let's say just to delegate that read-only authority, I'm going to decompose the top-level authority. So I was given a capability that referred to this editor object. I did a view source on that, and that returned to me a list of all the smaller authorities that it's composed of. So now I'm going to grab one of them. I'm going to grab the authority to do a read. I'm going to do a little URL concatenation here, which under normal circumstances is done for you by your browser. And so I just took that authority that I plucked out of the hierarchy there, and I did a get on that. And you can see that all I've got here is the source. So let's do a view source on this one. And Firefox has put it off the screen again.
Tyler?
Yeah?
I've taken your browser out of full screen.
It's not in full screen mode. Right. Actually, I know what I might be able to do. Maybe I can... Nah. Anyways, the only thing that's in this view source is the text. There are no more authorities in this source. Yes?
So do you Does a web app have to publish a schema of allowable capabilities that client can have, or I mean, each resource has, and what you can do with the resource?
Well, it depends. So if you want other people to write software that's going to interact with yours, then it's useful to tell them what sort of things you have to interact with. And so you might publish a schema that says, when I give you this top level authority, if you do a get on it, these are the following smaller authorities that you will get. And so then people can use that information to write clients which will interact with your server. And so it's a useful thing to do, but I wouldn't go as far as saying required. Another question?
I got the key to do something to my friend.
Mm-hmm. Yes. And so that was the other property that we wanted. In these base references, we wanted to make sure that if I have the authority to do something, I can pass it to you, and then you can do it in exactly the same way that I could. And so that's a good thing. Exactly. And that's where we use these core patterns here to build up abstractions that do those more sophisticated things using these simpler units. And so what I've been showing here is a direct delegation. In Mark's talk, he talked about a pattern called the caretaker. And the way that works is I've got an authority that I want to delegate to you, but I may want to take it back at some later time. And so what I do is I construct a new reference that all it's going to do is forward any messages you send to it to the underlying reference. Okay? And I pass that newly constructed reference to you. And so now you can use that reference exactly the same as the original. In fact, you can't tell the difference between it and the original. But then when I decide, hey, I'm tired of collaborating with you, I'm going to cut your access off, I kill off the reference that I sent to you so that it no longer has a pointer to the underlying one. And so when it tries to forward messages now, it's forwarding them into null, and nothing happens. And so I've actually got the caretaker pattern implemented in this simple web service that we've been playing with here. And so I'll take a little break again from the presentation just to show you that. So the way that works is, if you can see the key up here, this key starts with the number 3. And so were you guys to connect to this URL, you would have the same authority over this object that I do. But let's say I wanted to give you temporary access. I wanted to construct a caretaker for this capability. What I can do is click this deputize button. And what that does is it constructs a caretaker and returns all of the proxy references that will forward to the underlying ones. And so if we look up there in the URL bar now, we've got a new key. This one starts with the letter M. And so were I to give you this capability, you would be able to come down here and say, aha, Menitine. And I said, well, ha-ha isn't really a very useful comment to make. I'm going to revoke your access. I'm going to click the refresh button on there. And so this authority that we have, the one with the M, when I do a get on it now, it says, oh, these permissions have been revoked. I'm not able to forward anymore. Had we hit the submit button, we would have gotten the same message. But I can still go back to the original one here. And if I refresh on it, it's still good. Your comment that you entered is still there. I can delete it now if I choose. But my authority is unaffected by the fact that I created and then revoked your access to this object. And that's a very simple and accurate demonstration of how the caretaker pattern that we were talking about last week works. So I'm burning through time here, so I'm going to move on in the presentation and go to the next pattern. Oops. So another useful thing to do on the client side, what I just showed you was, well, I've got access conceptually here to all these invocation points on the server. There's different places where I can send invocations, different parts of the graph I can navigate to, and I can pluck out my access to one of those. And so you can think of that as plucking out the entry point to an operation. Sometimes another useful thing to do is after I've sent a request to the server, I want to pluck out my authority to receive the response to that request and give that to someone else. And I might want to do that because I want to protect my authority to issue the request, but I'm going to let someone else handle handling the response. I want someone else to do that for me. And so one of the things you get when you've got a capability protocol for interacting with a server is you've got the ability to reify a promise for the response to a request. And there are different ways of implementing that. In the system that I use, the way it works is the client, when it sends in a request, can associate that request with an unguessable secret. When the server receives that request, it will hash that secret and associate the response with the hash. And so essentially the hash of the request secret becomes the response secret. And now anyone who knows the response secret can fetch the response. And so as a client, one of the things I could do is I could issue a request. And since I generated the request secret, I know it is, so I can hash it right away as soon as I've generated the request. And I can pass that hash off to the person that I want to delegate the response to. And right away, I've stepped out of the picture. I'm no longer in the runtime chain. The person I delegated to can go and directly fetch the response from the server. So it's useful in scenarios like that when you want to delegate access. It's actually even quite useful when you're just delegating to yourself. If you've noticed here, one of the things you can do is, since I've already got the reference for the response, if I've got another request that I want to send to the response of my first request, I can just send it down the line right away because I've already got the reference for the response. And so you can pipeline out your requests in this way, and you get some substantial runtime savings doing that. It makes a noticeable improvement in a distributed application because in a distributed application, latency is your biggest enemy. Another question at the back.
What if the request doesn't reach the server before the request on the other side of the hash of the...
Yeah, so the person who has the hash gets a 404 when they try, gets a not found.
Well, maybe the network is
and
connected.
yeah, and so you might have lost the connection before the request got there. You might have sent the hash to the other guy faster than the request got to the server, and he beat you to the server with the hash. All kinds of things like that might happen. And so in that case, if the other guy wins, he receives a not found from the server because it doesn't know about that reference yet. And so then there's a recovery protocol where the person who receives the hash remembers who he got it from. And so he goes back and says, hey, you know, the hash that you gave me didn't work out. Give me the response that the server sent you. There's some variations you can do on that too. All right, so now we've got our two client-side patterns. You'll notice that they're all delegation patterns. When you're trying to get pieces of software to collaborate, that's all about delegation, right? Me collaborating with you means me giving you some of my stuff and you give me some of your stuff, and that's delegation. And so all of this is about easy ways of doing delegation using capabilities. Oops. Damn. All right, server-side patterns. So a common problem you have whenever you're doing any kind of software engineering is part of your server might be sort of like a state machine where there's a certain event that has to occur before a subsequent event makes any sense. And so you've got a race condition in there where if that second event somehow occurs before the first, you've got a bug in your server. And you know, I can tell you that chasing down bugs in server software, these kinds of bugs represent a substantial portion of the bugs that you're chasing down and trying to fix. And so how do we go about solving this problem when we're using capability software? Well, the easy thing to do is to say, well, if I don't want that second event to occur before the first, then I don't produce the reference for the second event until the first one has happened. And so event A, when it gets processed, it returns a reference that can be used to cause event B. And so what I've done there is I've taken this causal relationship, this timing problem that has to be solved in terms of when things are happening in the system, and represented that constraint in the way the reference graph is being constructed. I've taken a timing problem and turned it into a reference graph problem. And so that's one of the common patterns you'll see when you're doing capability-based design. It's representing everything in terms of the reference graph. earlier we saw how to solve an access control problem by the shape of the reference graph that was constructed. And now I'm going to solve a timing issue using the way in which that reference graph is constructed. It's the common recurring theme here that you'll find is that a reference graph is a very powerful tool for representing constraints, a very flexible tool and an easy one to use. And so I've also got, I'm just trying to have 15 minutes. I've got an example of this code here as well. And so I'll show that to you real quick. So this web service that I've been showing you, it actually can do a bunch of interesting things. It's actually an access controlled wiki. And so I'm going to create a new entry in this wiki here. And the wiki is actually sort of, it has a fair number of features. And one of the features of this wiki is that when you create an entry, it can have multiple kinds of entries. You can create not just pages in this wiki, but you can create redirects to other pages. And so after you've created a new entry, the system wants to know, okay, well, are you expecting to put some text in here? Or do you want me to redirect when people connect to the read-only authority on this? What exactly do you want me to do? And it's going to present to the user a different style of editor depending on the type of content that they want to store in this slot. And so after you've created a new slot, before you get access to the editor, you have to tell the system, well, what kind of entry am I creating here? So the last one I showed you was a code page. I guess we'll create a different one this time. I'm going to create a redirect. And so I get an editor here that looks a lot different than the one we saw last time. And so what's happening there is I'm forcing the user to initialize the state of the editor before they start editing. And the way I'm doing that is just by the shape of the reference graph. And so what I did is when I hit the initial create button to create this slot, the thing that was returned to the user was that assign authority I was showing to you earlier. Remember when I showed you the view source? There were two interesting authorities in there. There was the authority to overwrite the text that was currently in the slot. And there was the authority to fetch the slot, the text that's currently in the slot. Well, after they created this new slot, I didn't return to them that full package of authorities right away. Instead, I just gave them that assign authority. And so the only thing they could do with this newly created slot is assign something into it. And by doing some introspection on what they assigned, I figure out what kind of editor they want, and then expose to them in the return of the assign operation, pointer to full editing authorities over this slot. And so consequently in my code, for this, I don't have any sort of state variables where I say, have I been initialized yet? If not, do the following checks. It's just that logic doesn't even appear because it's implicit in the way the references are being exposed to the user. And so why don't I actually skip and show you the code for that right away so you can see exactly what I'm talking about. Yeah. So when I clicked on that create button, it resulted in a call to this define thing where the topic was the empty string because we were just creating an unnamed slot. And the return of this define thing is a pointer to the assign method on this author object that I'm going to construct. And so as a result of this define, I'm going to construct a new slot on the server here for holding on to user content. And then I'm not going to return this pointer to the user. I'm just going to give them a pointer to the assign method on this object. And so by constructing my return in this way, I don't need sort of a Boolean variable in here saying, have I been initialized yet? And if not, act this way, otherwise act the other way. Basically, all the code in there can assume that the object has already been initialized because the access control mechanism guarantees that by the time any of these other methods have been invoked, everything's already been initialized. All right, I'm going to go back and do our final pattern here. Oops. Rights amplification. All right, so one of the things you may have noticed when I showed you that graph of authorities that you get from the editable text blob is that there was sort of a hierarchy to these authorities. I started out with a very powerful authority, the ability to read and write this blob of text. And then when I decomposed that, I got less powerful authorities. I got the ability to read and the ability to write and some other property authorities for creating caretakers. Well, that's useful so long as it's okay within the sense of the application to always be deriving less powerful authorities from the powerful ones and having that structure of authority. But sometimes, for application reasons, it's interesting to be able to do the opposite. You've got a less powerful authority, but you'd like to provide the user with a convenience link to a more powerful authority. So I'll give you an example of this right away. So I had the read-write authority over this blob of text, and I have full read-write authority. Then I split out the read authority and delegated that to someone else. And so were I to come upon that, let's say they passed that read authority back to me somewhere, or I found it somewhere else, were I to come upon, I could see that, oh, well, this is a read authority, and I know somewhere I've got the write authority for this text, but I don't know how to find it right now. How do I go about editing this page that in front of me right now is purely read-only? How do I go about doing that? And so I'll show you how to do that. We're going to solve it using rights amplification. Basically, I'm going to take the more powerful authority, the ability to read and write, and I'm going to stick that inside of a box that can only be opened by someone who has a corresponding unsealer for that box. And so when I give you read-write authority over something, I'm also going to give you an unsealer. And now, if ever you come across the read authority for one of the pages that you have edit authority for, you just unseal the box that's attached to it, and that gets you to your editor. And so I'll show you that in action in the browser here. So let's go back to our edit page. And let's go down to the read-only authority. And I'm just going to bookmark this. So I've got this reference here for the read-only authority. And I'd like to be able to edit this because I want to change the content, but I don't have my editor accessible to me right now. So since I'm the creator of this wiki, when I first created this wiki, I got the special unsealer authority. And so since this is my wiki, even if I delegate write access to certain pages to other people, at the end of the day, I get to decide what goes in here because it's mine. And so when I created the wiki, I got this edit authority. And so what I'm going to do is take this read-only authority here and send it to my unsealer. And it's going to unseal the box that's associated with that read-only authority and put me in the editor for it. And so this is what's called rights amplification. And so whenever you get yourself into a scenario in your application where you've got the user in a very low power situation where they've got a very, very small amount of authority, but there's some other more powerful authority that's relevant or applicable to it, you can put a nice user interface on that by just sticking those powerful authorities inside of a box on that less powerful authority. And then you've got a fairly convenient user interface, as you see there, for getting at those authorities. Question at the back again.
When you say box, is it an encrypted string inside the result return, or is it actually a capability you invoke? And is it a client-side operation?
Yes. To both answers, both questions rather. So the way this is implemented here is the box is just an opaque object that has the powerful authority encapsulated inside of it. And there's another object, the unsealer, which is the only object which is able to break encapsulation and pluck the powerful authority out of the box. That's the way it's implemented right here. As you very quickly figured out, though, you could also implement this using cryptography. And so I could serialize the powerful authority, encrypt it using a public key, and then the unsealer is the private key. And so you could do these unsealing operations without any network round trips. So I promised you a small number of patterns seen in a few number of ways, and we've come almost to the end of the talk, so it's time for the conclusion. And so the basic point that I want to make here is that when we're designing software that uses authority, and we've got two major problems that we need to solve. The first one is we need to find an abstraction for representing the state of the application that closely corresponds to what the user wants to do. If the abstraction that we create doesn't closely correspond to what the user wants to do, the user ends up making decisions that we don't expect in the user interface, and we end up calling them stupid users. And that's not the end result that we want. We need to find an abstraction that closely matches what the user wants to do. That's the first and most difficult problem. Once we've done that, we then have to create an implementation that as faithfully as possible implements that abstraction. And if we fail there, crackers will let us know about it. So those are the two hard problems we face. And the point I want to leave you with is that reference graphs are a very powerful language for thinking about both of those problems. In trying to come up with an abstraction that meets what the user wants to do, you've got a very flexible language when you're thinking in terms of reference graphs. And then when you're implementing that, there's a straightforward, as we've seen here, a straightforward way of implementing the precise semantics of what references mean. And so we can get ourselves some fairly strong auditing guarantees that we've implemented what we thought we implemented. And so that's the point I want to leave you with. And thinking back over the patterns that I showed you how to structure information using a reference graph. I showed you how to implement an access control policy using a reference graph. I showed you how to solve a causality problem using a reference graph. And if you think about it, solving that, what actions are you allowed, does this application support? And then in what order are these actions allowed to happen? And that covers a fair amount of what's involved in designing an application. And so I think we've gotten a little taste of just how powerful it is to think in terms of these reference graphs and implement them with capabilities. And the other neat thing about capabilities is that you guys very obviously like whiteboards, and drawing graphs on whiteboards is very easy. And it's a wonderful thing to have a design review when you can go and draw your design on the whiteboard and criticizing it as a matter of erasing certain lines and repositioning them in another place. And you can be very specific with other designers about how you're intending to change the system and have very productive meetings. At least we found that to be the case. All right, so I've got 4 minutes left, and I'll open it up to any remaining questions. Yes, another question at the back.
I have a question. You described delegation where Alice is delegating for your Carol Bob. But you implement the distributed system in the caretaker pattern. Can you do that without still requiring, where's the caretaker implement the caretaker going Alice, which still requires all requests to go through Alice between Carol and Bob? Where could it be, where's the...
So that's one possibility, is that, right, sorry. So the question was, I understand the caretaker pattern. I can see how that lets me create revocable delegations. But what are the implementation implications of that? Where does the caretaker object live? Where do I have to host that? What does that do to the network traffic? That's a very good question. And so the first answer that the questioner suggested was that, well, if Alice is going to send a revocable delegation to Bob, then one place to host the caretaker would be on Alice's host. And so that means that when Bob wants to message Carol, all that traffic is going to end up going through Alice's machine. And that very well may not what you want. However, in the example that I just showed you here, the server, the equivalent of Carol, the text editor that I showed you, it had built into it the ability to create caretakers on the same host that was hosting the text blob. Okay, and that was functionality that was sitting on the Carol server. And so in that case, Alice instructs Carol to create a caretaker, and then Alice delegates the caretaker that resides on Carol's machine to Bob. And now all the network traffic is just going between Bob and Carol's machine, the same as it would have otherwise. All right, last 2 minutes for questions. Another question.
So is the output, what you're trying to generate in your group, going to be just documentation, presentations of this sort, or are you trying to generate software to make this sort of thing easier to do? What are you trying to create?
Oh, all of the above. So I've been working on systems of this kind since 1998. The latest incarnation of the tool is available on SourceForge. If you go to Waterken, W-A-T-E-R-K-E-N, so 2 words, water, and then Ken, K-E-N, sourceforge.net, you'll find a fairly large body of source code there. It's a server implemented in Java that provides you with a server that can host code that looks like this. It looks like this. And so this code that I showed you earlier, it looks like just normal Java code, but I was interacting with it over the web. And so there was some magic somewhere. And the answer to that question is the water conserver. It knows how to connect to Java objects like this using introspection and create a capability-based web interface to them. And that's all open source code under the MIT license that you can download and use as you see fit. There I am. Any more questions? Okay then. Thanks for your time.